Hello, and welcome back to New Scientist Weekly, your curated selection of the week's science stories. I'm Timothy Revel in New York.
And I'm Christy Taylor, somewhere in Florida. This week on the pod, we'll talk about new insights into mammalian menopause and why it's such a complex question to investigate. Plus, a quantum computer has crushed the 1,000-qubit threshold, more than doubling the previous record. And Tim, why did the chicken look in the mirror?
To see its other side?
No, to learn if it had self-awareness.
Of course. And we'll also be revealing the final answer to our series of head scratchers, all coming up on the show. But first, almost a year has now passed since OpenAI first released the AI chatbot known as ChatGPT. Today, ChatGPT has about 180 million active monthly users, and its underlying AI is powering Microsoft's Bing Chat along with plenty of other commercial services. But researchers have been discovering all sorts of ways that ChatGPT's AI can be manipulated to dispense harmful advice, including advice on terrorism, and even providing the code needed to hack or damage computer databases. Technology reporter Jeremy Su is here with us to talk more about it. Hi, Jeremy.
Hey, Tim.
So this all sounds pretty worrying, and OpenAI, they're constantly updating the technology to try to avoid these sorts of things. So how did people manage to get around the safeguards?
Yeah, that's right. OpenAI keeps sort of releasing new versions of the AI models behind ChatGPT, such as GPT-4. The company has also implemented safeguards that are intended to sort of prevent the AI from providing potentially harmful answers, even when users are deliberately trying to provoke them. But researchers at Brown University showed that they could still get GPT-4 to give very detailed answers in response to questions about how to build homemade bombs or perform illegal insider trading. And the way they bypassed GPT-4's safeguards was by using Google Translate and by querying the AI using certain languages, such as Zulu or Scots Gaelic.
So why those languages in particular? They seem maybe a bit random at first glance. So what is it about those that make them particularly good for subverting OpenAI's safeguards?
Right. The researchers specifically focused on testing examples of what are known as low-resource languages. So even though these are spoken by more than 2 billion people worldwide combined, the languages are not well represented in AI training datasets or in the development of large language models such as GPT-4.
You know, Jeremy, it sounds like this demonstrated vulnerability of GPT-4 actually also highlighted just a bigger problem for AI developers. You know, the fact that these languages are so poorly represented in the first place.
Yeah, exactly. If the tech companies want their AIs to be multilingual and to handle queries in a lot of different languages, they can't just build safeguards into the English or Mandarin Chinese version of their AIs and assume that those safeguards will automatically carry over to other language versions.
And we should note that the Brown University researchers did tell OpenAI about this language exploit prior to self-publishing their paper online, but OpenAI has not said how it may have handled this or whether they even handled it.
Right. OpenAI did not directly comment on either this or another study that revealed a completely separate security issue involving ChatGPT. In that second study, an international team showed that ChatGPT was among 6 AI tools that can produce malicious computer code that's capable of compromising online commercial databases. So the potential harms there include leaking sensitive information, temporarily disrupting access by overloading the database servers, or even deleting critical data.
Yeah, that sounds pretty bad. How did they manage to do that? How does it all work?
The researchers basically exploited the fact that all these AI models can translate people's questions into the SQL programming language, which is commonly used to interact with online databases. The researchers also pointed out that ChatGPT and these other AIs did not really warn users that the AI-generated queries may be harmful. But on the bright side, the researchers do say that OpenAI appears to have fixed the exploits that they revealed. However, down the line, even if tech companies take a more cautious approach to deploying these AI-powered services, it's likely we'll be seeing other AI vulnerabilities and exploits well into the future.
Now on to a story about a process half of human beings will experience in their lifetimes. Menopause, where our bodies stop releasing egg cells for fertilization and all the accompanying hormonal processes cease. Many biologists will tell you that this is unique to our species and a few toothed whales. But new research claims that menopause is in fact widespread among mammals, and it may be that our very definition of menopause is at issue here. So Michael LePage is here to help us unpack that. Michael, who's right? Is menopause common or rare?
Well, I think actually the answer is both, surprisingly enough. So this new research comes from Angela Goncalves, who's at the German Cancer Research Center, and she studies the aging of female mice. And she says that mice in captivity undergo something that's very much like the human menopause. But whenever she tells people about this, they always go, oh, well, I thought only humans had a menopause. And so, this sort of prompted her and a colleague to sort of look through all the other published studies to sort of find out what other mammals have a menopause, which is pretty hard to do as there are not actually that many studies out there.
So if mammals like mice, as Angela has found, have something like the human menopause, does that mean they also menstruate like humans?
Yes, so they do have a sort of menstrual cycle in the sense that the lining of their womb changes to get ready for pregnancy. But in most mammals, the lining of the womb is simply reabsorbed without any bleeding if there's no pregnancy, or of course in women, the lining of the womb is shed. So that's the difference. So other mammals don't have periods in exactly the same sense that we understand. And when biologists talk about the menopause in relation to other animals, what they mean is that these animals stop being able to reproduce. And they stop being able to reproduce because they stop producing or stop releasing eggs, what's called the oopoles. And it's not an easy thing to study because there are only a few animals where we know enough about them that we could sort of measure the levels of hormone in the blood and say this animal is or isn't producing eggs still. So in most cases, we just got to look at sort of where we've got data on what age these animals sort of stop being able to have offspring.
Yeah, well, that seems like something that would be measurable. So what did she discover?
Well, she could only find reliable results for around 100 mammal species, but what she did find is that the vast majority of those mammal species, the females do stop producing eggs if they live long enough. In fact, in those species, they sort of typically stop reproducing somewhere between a third and 2/3 of the way through their maximum possible lifespan. And Goncalves says, this isn't entirely new. She says other people have sort of come to the same conclusion. It's just, her studies is the sort of the biggest and the best one that's been done so far.
Yeah, so by this definition, that would mean that menopause is actually quite common, at least if those 100 species are a good representation, but certainly more common than we often talk about with menopause.
Absolutely, but the crucial thing here is that these results are based almost entirely on studies of animals in zoos, and animals in zoos typically live a lot longer than those in the wild because they're not being sort of eaten by predators or getting diseases and so on. So the thing is, if the question you're asking is, would most female mammals undergo the menopause if they live long enough, then the answer seems to be yes, they would. But the other claims that we mentioned in the beginning, that this idea that the menopause is very rare in other mammals, that's based on studies looking at animals in the wild and whether those animals in the wild continue living long after they stop being able to reproduce. And so if the question you're asking is, do most female mammals in the wild undergo the menopause, then the answer is no, because they don't live long enough. So in that sense, it all depends on your definition. Both are correct depending on how you look at it.
And it really sounds here like which definition you want to use might depend a lot on what you're actually trying to understand about animal biology. Is that right, Michael?
Yes, exactly. So Goncalves is studying aging. She's interested in what happens to animals that do survive to old age. But a lot of other biologists are looking at the menopause from an evolutionary point of view. They're interested in, what role does it play in animals sort of surviving and the success of their offspring. And if most wild animals are not surviving long enough to reach the menopause, then from an evolutionary point of view, it's irrelevant.
Each week, we bring you some of the most fascinating news in science, medicine, and technology. But we also play scientifically informed games of choose your own solar system adventure. And this week on Dead Planet Society, Chelsea White and Leah Crane choose the worst adventure they could think of, creating the worst planet of them all for human habitation, with inspiration from local favourites like Mars and Mercury, and some of the least habitable exoplanets so far discovered.
And as spooky season culminates in Halloween next Tuesday, we have something special for you in Culture Lab, some visceral histories of famous body parts as we talk to medical historian Susie Edge. From King Louis XIV's fashionable surgeries to the man who spent a lifetime with his stomach open to the world.
He was accidentally shot in the chest and the abdomen at close range. A local military surgeon was called, a chap called Beaumont came along and had a look, and what he found, he described the scene. He said there were ribs and lung sticking out, and he could see the breakfast as well that St. Martin had was oozing out. And he put him back together, and all around the wound healed, but he was left with this patent hole into his stomach.
That's coming Tuesday.
Speaking of spooky season, we've got a treat for you this week. In the lead up to Halloween, we've unlocked 7 of our scariest science stories over on newscientist.com. If you've ever been curious about the scientific line between life and death, the psychology of our love of horror, or why ball lightning may be a phenomenon from the 4th dimension, jump scare your way over to newscientist.com/Halloween for reading Best Done in the Dark of Night.
Ooh.
All right, now we're going to finish up our book giveaway with puzzle maestro Rob Easterway, author of the New Scientist book Head Scratchers, which is out this month. He's been giving us puzzles to try, and last week's, our final puzzle, was all about Farmer Giles, who had a pregnant sheep.
Now, this sheep was pregnant with non-identical twins, and he'd done a test at the vet to confirm that at least one of the 2 lambs was a male. And Rob wanted us to try to figure out what is the probability that one of the 2 lambs is a female. Brace yourself, this may be a controversial answer.
I think a lot of people would say, it's maybe more likely that they're both male, or it's going to be 50-50 boy-girl. The correct answer is actually there's a 2/3 chance that the other one will be female. And why is that? Because we know at least one is a male, so the 2 lambs are going to either be male-male, or male-female, oldest, youngest, or female-male. And each of those is equally likely. So the chance of a male-male is only 1 in 3 of those. So the chance there's at least one female, or there will be one female, is 2/3. This is a question that has caused people to write in angrily to columns for years. So good luck coping with listeners who say, I totally disagree with that solution and give you pages of proof. I am pretty confident I have presented this in a way where 2/3 is the right answer.
Congratulations to Simon, Harriet, Alan, and Dee, who all sent in the correct guess.
And if you're mad about this answer, of course, Christie's home address for angry letters is...
Hey, shouldn't we be giving them Rob's? Anyway, thanks everyone who sent in guesses. We'll draw 5 winners at random from everyone who emailed us, and you'll be sent a free copy of Rob's book, no matter how well you did.
Quantum computing has reached a new record. Researchers have built the largest machine to date in terms of the number of qubits it has. And to top it off, quantum computers are normally pretty unstable, producing noises and glitches very easily. But this new machine has qubits that are more stable than any we've seen before. Or so that's what the makers behind it say, anyway. Reporter Alex Wilkins is here to tell us all about it. Hi, Alex.
Hello. So I'll give a quick refresh of what quantum computers are for those of you who aren't so familiar. So they work a bit like regular computers, except instead of using bits, which can have a value of 1 or 0 to do their calculations, they use quantum bits, or a shortened version of qubits. These can have multiple values at the same time, and they use the weird properties of quantum mechanics, as well as lots of other cool technology to have more capabilities than normal computers. Now, roughly speaking, the amount of qubits you have in your machine is proportional to how powerful your quantum computer is. And we have now just passed the 1,000 qubit milestone, with a company, Atom Computing, claiming they've made a quantum computer with 1,180 qubits, which is nearly 3 times the previous best of IBM's Osprey computer, which had 433 qubits. But there are many, many caveats here. It's not a simple equation of more is better.
I'm really interested to get to some of those caveats, but first, could you just tell us a bit more about this particular quantum computer? You know, how exactly did they manage to make a machine with so many more qubits?
Yeah, so this company, Atom Computing, they specialize in making a kind of quantum computer that uses neutral atoms as its qubits. So companies like Google and IBM, they make their quantum computers using superconducting wires, which have to have these huge refrigerators, and they're super cooled to extremely low temperatures for the superconductivity to work. But Atom Computing instead uses ytterbium atoms, or an isotope of ytterbium, trapped in laser tweezers in a large 2-dimensional grid. These ytterbium atoms lend themselves really well to quantum entanglement, which is this strange quantum effect where qubits can be linked together so that measuring a property of one reveals that of the other. And they're also more stable. I won't go into the technical details, but the qubits in Atom Computing's machine last for quite a long time, whereas the qubits in IBM's machine last for quite short amounts of time. And that's really important for error correction, which I'll get into a bit later on. But one important technical detail of these qubits is instead of using electrons, which all the previous machines have used, these ytterbium atoms, they can use the nuclear spin, which is a bit like a spinning ball, that sort of property, something spinning, but it's a very quantum mechanical property. And because it's located in the nucleus, it's protected from all of the sort of effects outside of there. So these lasers that they use to trap the qubits, they're really powerful. And if you're using your electrons as your sort of computing device, then it can get disturbed by the lasers and they can get knocked off course. Because they're using the nucleus spin, then they're really protected from all these effects and so more stable and they last for longer.
So this all sounds great on paper. You mentioned caveats. What are they?
Yeah, so you can have qubits and you can have as many qubits as you want, but if you can't perform computations on them, which is something called performing gates or logical gates on your qubits, then they're not much use. So this company has more than 1,000 qubits, but they haven't yet demonstrated that they can perform gates on all of them at the same time. So now's probably a good point to talk about error correction. So today's machines are in the noisy intermediate scale era, which basically means there's too much background noise and errors in the qubits to perform reliable calculations. Now, we know in theory how to correct these errors, but you need loads and loads of qubits. Some estimates is that you need 1,000 qubits to do error correction for every one useful qubit you have. So while having more qubits, as in Atom Computing's machine, doesn't necessarily mean better performance, if you have more of them, then you're more likely to be able to do this error-free quantum computing.
But have they managed to do anything useful with the machine yet? And if not, how long are we waiting until they can?
So the short answer is no, they haven't done anything useful with it yet. There are very little details about what they've actually done on their machine. We just know that it exists and that the qubits have these certain properties. And as to when we'll be able to do it, it really all depends on how fast we can get to that large number of qubits. So many, many thousands, much more than the sort of the 1,000 we have at the moment. The Atom Computing CEO told me that they aim to multiply their total qubit number by around 10 every 2 years. So if we're lucky, we might see something useful this decade. But again, there's another caveat here that it's not just the amount of qubits you have. It's really sort of how you're using those qubits, how many of them you can use at the same time. And we still don't know how many they use. There's no accompanying technical details. And that makes it really hard to compare to other machines that we've seen from companies like IBM and Google, who really in detail show how many of the qubits they're using and what they're doing on these machines.
When you want to investigate an animal's self-awareness, there's a fairly well-known test in the animal cognition world. You place a mark on the animal, somewhere they can't see, then you let them look in a mirror. If they investigate or touch the mark while looking at their reflection, it's a sign they may be recognizing that the animal in the mirror is in fact them. Not many animals have passed this test, though humans and magpies both have, and in many cases, claims of passing are controversial. So it's big news that now chickens may also recognize themselves in the mirror. But this research comes using a completely different kind of mirror test. Senior news editor Chelsea White joins us from Portland, Oregon. Hey, Chelsea.
Hi.
So, Chelsea, I've got to ask, why did the chicken look in the mirror?
Well, reporter Jake Buehler has the answer for us. As you mentioned, researchers generally agree that animals like humans and other great apes and dolphins have passed the dot or mark mirror test. But other animals have done so with more controversy, including things like penguins and manta rays. That's because results from this test can be pretty variable. That's because investigating a weird mark isn't a particularly natural behavior for a lot of animals. So a research team at the University of Bonn wanted to look at chickens through the lens of behaviors that are actually part of their day-to-day life.
So if I'm a chicken on my schedule today, I have things like scratching, pecking, laying eggs, eating bugs. Any of these behaviors involved in the test?
Well, in this case, it was a rooster's natural instinct to warn other chickens of danger, which is part of their job is defending the flock. So they'll loudly call out to alert, their chicken companions, but they generally don't make warning calls when they're alone. So the research team set up some roosters in pens, either alone or with another rooster in an adjoining mesh pen so they could see them. And then some of the roosters got mirrors on those dividers between the pens. And to simulate danger, the researchers projected the silhouette of a hawk on the ceiling.
This seems like a pretty creative and cunning approach. I really like it. So
Mhm.
if the rooster gave a warning whilst there was no other chicken, it was just their reflection, then you could infer from that that they don't think they're alone, and therefore they don't recognize their reflection as them. Is that about right?
Yeah, exactly. But in this case, the roosters called out warnings significantly more when there was another rooster next door than when they were alone, either with no mirror or when they saw only their own reflection. And also, if they had a neighbor, but that other rooster was behind the mirror, so they couldn't see them, they were also less likely to call out. So that suggests that seeing another chicken is more important to them than, say, smelling one or hearing one. And altogether, the researchers say that this points to roosters potentially being able to recognize that their reflection was just that, it was themselves. And it might hint that self recognition is more prevalent in the animal kingdom than we've given creatures credit for. It might be that we just don't have the best test for each species yet.
It's so interesting, this. It's like, just think, in the natural world, there's so few times where you actually come to see a reflection, apart
Yeah.
from maybe in like some water or something when it's a bit vague, but it's very unusual to come to see yourself in a mirror.
Yeah, particularly a reflection that is vertical, right? Like if you're seeing it in water, you're usually seeing it horizontal on the ground. Yeah.
Yeah, very weird. So I have to ask, how do the chickens do on the original mirror test? Is, the one with the mark, is that something they've passed before?
Well, no, they fail.
Yeah.
And that's why one outside researcher said he found that this method of testing for self recognition is exciting. And it's evidence that we should maybe move away from the mark test, especially for, non primate animals that don't have hands that are available for investigating a strange mark on their body in the way that we might or a primate might. He also says that designing tests around an animal's innate behavior, it's going to require us to be more creative and clever. But when we work within that context for an animal, that's the best way to see what they know about themselves.
So as we're recording this, it's nearly lunchtime in the New York studio, and I'm getting particularly excited about some new work on perfecting vegan cheeses, specifically getting them closer to the flavour of dairy cheese with some help from fermentation.
Oh, that's exciting. You mean we may be getting closer to vegan cheese with both good textures and good taste?
Yeah, I mean, I guess with this, it really depends on what you're after with a vegan cheese, because something I've found since moving to New York is that the tofu-based cream cheese here is just amazing. And I do eat dairy cream cheese, but the tofu stuff, whenever we get bagels in the office, that's what I opt for because it's really good. So this new research, that's about trying to make cheese, vegan cheese, that tastes exactly like dairy cheese. And that's often rarely the case with vegan cheeses. And so researchers, they made a cheese with pea protein, which can normally kind of have a kind of unappealing beany or bitter flavour. But the team made a milk with yellow peas, and then they fermented it in different blends of bacteria, similar to those used in the production of dairy cheese, and particularly those that produce lactic acid. And lactic acid from things like sourdough, yogurt, and kimchi.
I'm a big fan of lactic acid's work, yeah. So did they get tangy, delicious vegan cheese with cheesy texture and no notes of bean?
Well, yes and no. So within 8 hours, all of the blends fermented the milk into a firm texture, kind of like brie or another soft cheese. And then all of them, to varying extents, produced odours with those same aromatic characteristics of dairy cheese. But as for removing that beany taste and the compounds responsible for it, well, some were more efficient than others. So while all of this is pretty encouraging, the team need to keep experimenting to really perfect it.
Got it. Well, I've got a cool story for you about smart glasses that could mimic echolocation for people who are blind.
How does that work?
It's pretty simple in some ways. So some blind people already teach themselves to navigate with actual echolocation. They make a noise and can actually listen for the reflection of it to understand where different objects are, which I find absolutely amazing. But these glasses would somewhat simplify or automate that process. They've got cameras and little speakers in them, and via a connected smartphone app, we're trained with deep learning to recognize specific objects in the video feed from the cameras. So like a bowl, a book, or a bottle. Then when they perceive one of those recognized objects, the glasses can play a sound through the speaker. So for the book, the wearer might hear like the sound of a page turning.
That's really clever, but are they actually easy to use? How useful are they for someone who's blind?
Yeah, and that's something that the researchers did study. It's a very fair question. You want to create something that's actually useful for the people you're trying to offer it to. So they enlisted both blind or low vision people and then also sighted people who were blindfolded and presented both groups with a range of objects on a table. And the blind participants fared very well when asked to pick up a specific item using the glasses. They were able to do so correctly 81% of the time. The sighted people in blindfolds, by the way, only did it 73% of the time. Even better, the researchers found the blind participants seemed to exhibit no extra cognitive effort in using these glasses, which suggests that they were really easy to adapt to and therefore might be much more immediately useful as a tool for someone who wanted to use it. So the team is now hoping to develop that smartphone app that recognizes the objects for you. They're hoping to develop that to recognize an even wider variety of objects and also test how well it works while people are actually walking around, whether that's in their homes or out in the world.
That sounds good. I know with these tech solutions, they aren't always tested by the people who would ultimately use them. So that sounds like a really good approach. I have a question for you. Have you ever wondered how much your immune system weighs?
I had terrible insomnia last night over just that question, Tim.
Well, you can sleep again, as we have now found an answer to this. And of course, it depends on the size and age of the person. But as a rough guide, a 60-kilogram woman between about 20 and 30 years old has about 1.5 trillion immune cells, weighing around a kilogram or 2.2 pounds. And a 73-kilogram man has about 1.8 million immune cells, weighing in at about 1.2 kilograms or 2.6 pounds.
All right, so I would understand this to be a simple task if you're looking at one organ like a heart or a lung, but the immune system is all over the body. So how do you suss it out in terms of number of cells or mass?
Yeah, it's a good question. The research used existing studies that took a census of all the cells in the human body, plus lab work sampling lots of tissues. And then they also counted cells like your white blood cells, which produce antibodies, and your mast cells, which regulate the inflammatory response.
So is this going to be the cool fact that I pull out at a Halloween party this week, or is there something really practical about knowing this?
Well, why not both? It's helpful to know, for example, that while the macrophages that engulf and break down pathogens contribute about half the total mass of the immune system, they only contribute about 10% of the cells in our body. Or that white blood cells are actually rarely found in the bloodstream. They spend much more of their time in the bone marrow and the lymphatic system instead. And what the researcher behind this study thinks is that by being able to quantify immune cells like this, it will help us to better understand how the body fends off infections.
That's it for this week. Thank you so much for listening. You can find all the great journalism we talked about today in the show notes, and you can subscribe to this podcast on whichever app you're currently listening on.
And as always, if you like the great stories we're bringing you from the serious to the silly, please give us a rating or review on Spotify and Apple Podcasts. We'll be back next week, but that's bye for now.
Bye. "1,000 qubits when all you need is a bit." Sorry, that's my parody song by Alanis Morissette.
This podcast is produced by OG Podcasts. Find out more at ogpodcasts.co.uk.